Alright, so once the focus gets back, we can talk about this Audio 30 CC, which is actually unknown to me. So this is made by ALPINE. You can only see it by the serial number. The Japanese are very discreet about branding. And so I do have this on file, right? I have the Becker one, and I think there's two of those, is it? No. I have the Becker one, which is the 3302, and that's rather similar to some other models, and it has this audio mixer IC. And where do you put the sound in? What is up with this? I haven't done one of those in quite a while. So I have no idea what's going on over there. But anyway, and I have the ALPINE one, which this is basically the board out of the Audio 10 CD. It's ever so slightly different. They have some more power stuff over here. And this is using the Philips chip that is in the Audio 10 CD. It's a bit differently arranged. I think I've done a video on this. If not, once one comes in, I will go over the diagram. But this is a CM2299, so instead of 1910. And inside, it is totally different. So it is amazing how many different projects from Mercedes have the same face, right? There's the one from Panasonic, from Matsushita. That's only Japan and has different FM frequencies, completely different inside. The Becker one is completely different inside, and the ALPINE one, apparently there's two versions. And let's just quickly go over how I attack one of these mods. We won't go into actually making the little schematic diagrammy thing in Photoshop because, yeah, I'll probably just upload it later. But what is to be known, what is the first step? What is to be done initially is you have to check out the chips, and you're looking for something that handles audio. So over on this side, we can see they're actually piping the audio for the amplifier through this cable because no one bothered with the connector, because there's definitely one here anyway. And there's a bunch. This one I actually do know. It's a TEA6321T. I don't know why I had to read that out loud, but I have. And so what you want to do is check out the data sheet for that. So let's, I've Googled PDF datasheet, and this comes up. You have to go through a few clicks. Security codes 72459. I'm not a robot. Yes. All right. Sound fader control circuit, and what we want to go for is the block diagram, which is this in perfect form. And you can see there's a source selector that has a bunch of stereo inputs, 4 stereo inputs and 1 mono input. Now this is all fine and good. You can actually use these if the situation allows for it. But what is simpler in these cases, right? All of these mixer ICs have this going on. So immediately after the source selector, the sound path comes out and goes back in over here and over here. So we have pin 10 and pin 23, which will probably be biased at anywhere between 4 and 8 volts, thereabouts. And if you manage to blank out the AM wherever it's coming in, right, we'll have to actually find out where the AM is and destroy it, mute it completely. And then you can basically superimpose your sound on these pins. There's very little difference if you go 10 or 8, 23 or 25, right? It's just this capacitor in between. I don't know, to be honest. I don't remember ever having seen a difference. But anyway, they do have this little resistor and capacitor doodad over on these sides. I don't know ALPINE actually implemented it, but anyway, it doesn't matter. Any of these two pins for left and right. We'll have to see which one is which, to be honest. So this should be right and this should be left. And so we'll probably just solder some wires directly onto this. I have my stereo cable, which I'll just solder directly onto it. What is very important, you have to add some decoupling capacitors. You can see I've soldered them in over here because this actually sits at 0 volts and oscillates the sound above and below 0 volts, whereas this sits at 4 and oscillates the sound above and below 4 volts. And so you definitely have to do that, otherwise you're going to fry this and the little amplifier chip on here. You can have that mistake going on for a few hours and you'll be fine, but do not forget the capacitors. They're very important. I like using these awfully low rated 6 volts 100 mic SMDs. I don't know what footprint these are, but they're rather large and pretty expensive. But anyway, so next order of business is finding power and an enable signal. So I'm using these DC-DC converters and they have, let me see if I can bring one up. And these are super great. I love them. I use them for everything. And they have an enable signal, which is exactly what we want over here on the bottom. So to get these to play nicely, right, they will need to suffer some modifications, which I'll go over. But basically, we're going to find a 12-volt rail. So the main power rail, it can be on all the time, and usually it is. And we'll want to find a signal that turns on only when AM is on or when the radio's on. And that will feed into the enable pin. However, these come pre-installed with a pull-up resistor, this one over here. And these can really fuck up the logic in the radios. Because you have your radio turned off, you connect it to your car, this gets 14 volts, and then leaks the 14 volts through whatever resistor this is. I don't know, how big is it? 20K? 200K. So 200K resistor, it will leak some current into the enable pin, and that could be a problem, right? So first thing you want to do is pop this resistor off, like so. You can use a soldering iron if you're feeling fancy, but I almost never am. And I lost it. Jesus Christ. Fuck. I know it's here. All right. So the resistor is popped off. Make sure there's no solder bridges over here. It should be fine. And they have preset voltages. Do not use this pot, right? You could definitely adjust this to your heart's content. These can suffer up to 30 volts with no problem, and they're very, very stable and very low quiescent power and very good dynamic performance, right? They're very, very good buck converter chips. But so what you want to do is completely remove the pot, and this way you're sure you'll never use it. Alright, this is all lead free, so it pops off quite easily. I just like to do one more pass just to make sure all the little shrapnel is caught. And then you basically just bridge the 5 volt and you're good to go. And this is what I've done on this side, on this board. And so we have an enable signal, voltage in, anything higher than 5 is good enough, and audio in. And for this client in particular, he wants an aux in, which I've prepared over here, and a mic in, for which I'm supposed to have the cable somewhere over here. Over here. Right, so 2.5 millimeter jack for the mic. And so these are going to be a pain in the ass to route. I'm probably going to cut out a piece of this and then use this hole over here. This one here. I'll see. It's a pain in the ass. I don't want to deal with it today because it is a nice Saturday outside. Yeah, so next order of business would be finding the voltage that a V-bus that we can hijack and an enable signal. So let's bring the meter in and my Type-C to ISO radio connector doodad thing with ignition and backlight. So this is just going to ask for 12 volts, and we're going to pipe it in here. All right, now it's going to turn off when I connect the capacitors over here, and it should go back alive. Boom. All right, so radio's now on. Could put the code in. 22655, 22655, okay. All right, so ground is ground, and I would want something comfortable like these pads. Let's see how lucky we are. 7.5, all right. Does this turn off when the radio's off? Yes, it does. Holy shit. We might actually not need the enable pin on the booster, on the converter. So let's go AM and see if this stays alive, and it does. Yeah, not bad. So this is already a good spot. To be honest, I think I'll leave it here. I'll probably measure some more stuff. So this is 8 volts. Either AM or FM. This isn't good. I might wanna. So let's go AM and try and find the voltage here. Okay, FM. All right, so this would be an enable pin. Goes high when AM is enabled. And again, given how tiny this trace is, I wouldn't draw the 100 milliamps the Bluetooth board uses through it, right? So rather just get the main power from here and the enable from here. And yeah, sound goes in here, and that's it basically. I'll probably put up a little video film once it's done. But yeah, that's pretty much it. And let's hope the board on the front is the same with what I got, because those are a pain in the ass to reverse engineer. They really, really are. So it should be the ALPINE one, this one, right? And so I'm really hoping to find exactly the same board. It should have a number, so this one. Fingers crossed, otherwise, yeah, it's a pain in the ass. But anyway, there's a price for everything, so I can't complain. All right. Alright, so the proof of concept is working. The radio is very unhappy that it doesn't have its tape mech inside, so that's why all the beeping is happening. We might actually turn it off. So as I've mentioned in the previous video, which was shot about a month ago, this is the mixer IC, and we can see its diagram over here. Actually, get a proper zoom in. So this is the pinout, right? This little notch corresponds to a line over there, and we've discussed that the signal path comes out and back in, and the points I've selected are 8 and 25 to inject my right and left channels, and that is exactly what I've done. Now these stay at 8.4 volts or 4.5, I don't know. Actually, I don't remember. I think it was 4.5. So what you need to do is get some SMD capacitors or any capacitors, but if they're polarized, then make sure they're the right way around. And isolate this headphone amplifier from Texas Instruments, because this is hovering around 0 volts, as I've mentioned, and this is at 4.5. Keep repeating this because I've made this mistake many times and it's very annoying, and if you fuck one of these up, very hard to come by, especially in good nick. And as we can see, there's 50 variants, so anyway. Now with the sound being out of the way, ground was found over here. I'm in the process of populating the diagram. So audio, this is a very low res photo, but again, paste with the cock you've got. Now these are 3 vias which should provide quite some structural support over here. So I've used that for ground, left and right as mentioned, and I'm also showcasing the capacitors just so I don't forget them. Always on, preferably, so we know we can draw current from it. An always on supply. This basically is VBAT, whatever is coming in from the ISO connector in the back. And then ground, again, is pretty easy to find. And the next order of business, and what I've spent this night on, right, what is it? It's 12 in the morning. Is finding an AM enable signal. Now, sorry for moving around so much. This transistor slash MOSFET transistor, right, Q834, is definitely responsible for switching on the AM front end, which I believe is this, is on this side over here. I can't really get to its pins, right? And so all I could find that was also easily accessible from this side of the board was the logic level signal, which is 5 volts, I believe, like a very, very clean 5.00 volts when AM is enabled, 0 otherwise. So this will enable controlling the Bluetooth module with the AM switch, right? So you can see now it's connected, solid color, and it actually started playing, so we're gonna get demonetized. Not that I make too much money out of this. And then you go AM and then turns off. I go AM back on and turns back on. So this is exactly what we want. Connects automatically, everything works superbly. So what I'll be doing next is probably the most cumbersome bit. I'll take out the front plate and perform the magic that's required to control the Bluetooth module with these lower 3 keys. And again, I probably mentioned this before last month, and I'll probably mention it at the end. Make sure that your code does not contain 0. And make sure that the model you're working on doesn't use these to eject the tape, because I've had screw-ups from that class before. So yeah, that being said, this wraps up the audio and power supply side of the video. We'll come back once everything is cabled up. I am totally not going to do this today. Alright, so today's tomorrow, and very fortunately, this front plate assembly is completely different. Well, it's not completely different to the one I had before, right? The CM1999, but it is significantly different. So a lot of traces are going in totally unexpected ways. So unfortunately, I'll have to take a good picture of this, front and back, and annotate it in Photoshop. See how much of the old design we can reuse. I'll probably take some hints from it, but if the matrix isn't wired up the same, that's going to be a pain in the ass. But it's noon, so there's enough time in this Sunday. Let's see if I can keep track and focus. Alright, so it's about a month later. I'm supposed to skip town in like 4 hours, 5, 6, I don't know, probably less. And I don't got enough money, right? So I definitely, right, had to finish this radio. And it was almost done, right, for 2 weeks, but just everything was too hectic. Anyway, pain in the ass, right? First time I'm doing this, and has a slight issue with the biasing caps. I don't know if this particular one is a bit oldened or that's how all the chips in these work, but it does make this clicky sound with every volume change, right? So perhaps, I don't know. I don't have enough time to try everything that I would, and the client has been delayed massively. And I'm sorry, Simon, if you're looking at this. My best is rather weak. But anyway, right, so this is a fully decked out one, has the microphone jack and also an AUX in. Huge pain in the ass to route those through. I don't know if you can see this, but let me notice those two. Oh, and I forgot the screws. Yeah. This plate had to have a hole drilled through it, and that's the best spot I found for routing everything. I've added sanitary silicone just to make sure that the wires don't rub too much against the case. I need to populate those screws though, because I missed 100% of them. But these things have too many screws anyway. So yeah, I'll put the screws back in later, hopefully before I pack everything up. And let's just have a quick look at how I've done this. So in order to program the Bluetooth module, in this case it's a QCC3008, I believe. I'll link it up here in the description. But as far as the power supply and sound go, I found that these two spots have a constant 12 volt supply on them. We get our enable signal from this via over here. I hope this is clear enough. The photo is not the best, but yeah. I have never worked under so much pressure on a radio, so give me some slack. As far as the audio IC, audio mixer IC, these are the points I'm using, and these have the slight pop. Sound quality is super nice. But yeah, I think this about wraps up sound and power. And again, do not forget to add DC blocking capacitors, because this whole sound stage sits at about 4 to 6 volts, thereabout. What did I write on the back? Oh yeah, you have to take out this capacitor to nuke AM, right? Not have any of the AM sound coming in reach the IC, right? So we block it over here, and then the IC is completely quiet when it's selecting the AM output. And this I played with my new laptop's trackpad. It's quite artistic, and I think it adds about 1 megabyte to the JPEG. It's like 3 megabytes at quality 5, so anyway, totally worth it. This is not it, and this is it. So it only requires 2 links. You'll have to link this button with this via, and another long one. The corner of this IC, this SAW23, with this via over here, right next to the 1. Alright, and then as far as the cuts go, let me find something to point with. So we have this tiny trace over here, this one over here, right before the lowest most via. And what else? Over here we need to separate the IC, right? That's why we have the via. 4, right? You can see this very well if you shine a light from behind the board, right? Because this solder resist, this white one really messes up the situational awareness of a viewer trying to cut this trace. Anyway, so 5 is this middle button, has a little trace going to this via, and last but not least, the switch 424, is it? Yeah. This just has a tiny trace going up to this via, or I don't know. And once you do that, you can simply connect your play, common, previous, and next wires. Now this isn't as straightforward as it would sound because everything is super tight over here. So what I do is, again, shining a light from the back, you can see how much of this you can cut out, right? And so what I do is I Dremel out a slot over here, probably even less taller than, less deep than this little, what is it, trapezoid. And furthermore, you'll have some issues with this plate. So I also, but this plate, yeah. So this plate also has a little, right, the equivalent of this part on the back, right? I also shaved 1 or 2 millimeters off, about this wide, right? Just to make sure I'm not crimping into the wires, because right now it might be fine, but these things cook at 100 degrees, so over time they will melt through the, what is this, Teflon? It's not Teflon, I don't know. PVC, is it? Yeah. Anyway, so let's see it work, and I will be off to packing it. It'll be funny if it doesn't work though. Alright, and we should be live on here. And we are. Next. This is super rattly over here. Yeah, so that's about all. And long press on play will enter pairing. And what else? And play pause also answers and hangs up calls, because this one does have the microphone. And yeah, I think that about covers it. I am running out of steam, as you can probably hear. If you have any questions, or if you want to do one of these yourself at my place, let me know down in the comments, and have a good one.